All right. Good afternoon, all.
Good afternoon, sir.
ये कौन सा देख रहे हैं? पीपीएम पीडब्ल्यूएम है। हाँ, कौन सा लिस्ट आप देख रहे हैं? पुराना वाला लिस्ट क्यों देख रहे हैं? पीपीएम पीडब्ल्यूएम किधर है? Today we'll do the experiment 3, isn't it?
Yes, sir.
Today, what is the experiment? What is the name of the experiment?
Sir, realization of PWM and PPM in fiber optic links, sir.
पीडब्ल्यूएम भी हुआ है ना? पीडब्ल्यूएम I have uploaded the manual. You all of you just go through it, and by that time I will set up the experiment, connect the circuits. Go through the manual that I have uploaded now. इसमें तो आता है। इसमें अच्छा आता है। Students, please wait because there is some issue in the kit. Please remain connected. इसका मैनुअल कहाँ है? पीडब्ल्यूएम पीपीएम का इसका नहीं, मतलब वो पुराना वाला किट का है तो वो छोड़ दीजिए। यहाँ पे तो बाद में इसी से क्या कर रहे थे ना हम लोग। हाँ, इसका देखिए जल्दी। फंक्शन और है यहाँ पे। वो सब ठीक है। लाल कौन सा है? ये लाल है कि काला है?
ये लाल है। नहीं देंगे।
तो क्या है? नहीं है ना, ये भी दे सकते हैं।
टोटल फ्रीक्वेंसी का मेजर करा
कितना वही उसी में ना दिए थे। खराब है क्या?
नहीं सर, इसको खोल कर
बात होगा, कनेक्शन कीजिए अभी, वहां से वहां जाएगा, वहां से ट्रांसमीटर में जाएगा, नहीं ट्रांसमीटर नहीं, हाँ ट्रांसमीटर में जाएगा, ठीक है। उसके बाद ये वाला से डिटेल आउट से डिमोडुलेटर इन, ऑप्शन दे दीजिए, उसमें वही वाला स्केल का कौन सा स्केल,
চ্যানেল ওয়ানটা সব বন্ধ করে দিন,
हाँ
चैनल वन
চ্যানেলটা অফ করে দিন।
पता है तो ऐसा हालत क्या कैसे हॉरिजॉन्टल वाला है, चैनल टू का स्केल ये है, क्या रहा है? सेम प्रॉब्लम है, ये देखो ये हो गया PWM और कौन करो, ये तो आ ही रहा है, इससे कोई दिक्कत नहीं है, मॉड्यूलेशन नहीं हो रहा चैनल टू को एक साथ अगर देखना है तो ये दोनों एक साथ देखेंगे ना, चैनल टू, अच्छा चैनल वन, ये ऐसे देखना होगा, इसको प्रेस करके देखना होगा। इसका भी एम्पलीट्यूड थोड़ा कम होगा। Scaling पे। ফোনই আসতে থাকে। Students, are you present?
Yes, sir.
So I'll show the connection first. Okay, just see and we'll try to see the waveforms. Okay. उधर ऑन है ना उसका पूरा रेडी है ना उधर उधर ही करते हैं See, this is the kit that we perform the experience for PWM and PPM. Basically, PWM is what it is, pulse width modulation. So your input signal is the analog signal, and let us say it is a sine wave, and your carrier signal is a pulse train. So pulse train means of a particular frequency. So that frequency, you can change the frequency in this kit, and also for any analog signal you can perform the experiments. So here we have used 100 Hz analog signal. It may be more than that, but for better visualization, we have kept it at low frequencies. Okay. And the pulse train is of frequency 8 kilohertz. Okay, that we have connected the jumper. Okay, you can see the jumper. Is actually one kind of jumper which is used to set the frequency. So we have set the frequency, input signal frequency, analog signal, 100 Hz and certain magnitude. Then this is applied to analog analog buffer circuit. Okay. Generally, this is the process. First, it goes to some buffer area stage, and at the output of the buffer, we pass it through a block that is called PWM and PPM modulator. Do you see this?
Yes, sir.
Okay. So basically, the PWM is what? With the pulse gets modulated or gets changed according to the magnitude of the input signal. So if magnitude is low, then pulse width will be the low or at the lowest level, or the time period, that is half of the time period of the frequency that you have selected. And then if the signal increases, then pulse width will increase. So there are two stages. Here one is pulse width modulation output, PWM output, and another is PPM output. In case of PPM, the position of the pulse actually gets changed relative to the previous one. Relative to the previous one, position of the pulse gets changed. And this PWM circuit, modulator circuit, we can see from any book of communication that some op-amp is used. Okay. and it is operated in this comparator mode, op-amp with comparators. So at one stage, some sweep signal is used, and when the sweep signal is more or less than the input voltage, accordingly, the output will change. Okay? So that means there is some threshold level kept for the comparator circuit, below and above which the output will switch. And depending on that, the output remains high or low for a particular time duration. Okay, so that is actually one simple circuit. It is given in the manual, or for your understanding, you can see it from any book of communication. Probably it may be in or Lathi. Okay, and the output of PWM is applied to a monostable multivibrator. Okay, and monostable multivibrator you are now studying in PDSS. So basically, what happens that switch, it is actually a switch. So switch changes state when triggering pulse is applied. So according to the duration of one pulse, its age get changed. Okay? So that means if the pulse is wide, its rising edge or falling edge will change with respect to the previous one. So the each monostable multivibrator actually would need some trigger signal. Okay? Trigger signal. When trigger comes, trigger signal is basically a signal rising or falling signal. And it's either going from high to low or low to high. So when there is that kind of change, output switches from one state to another state. Okay. So and the output pulse duration is selected such that it depending on the time constant of the multivibrator circuit RC, it is generated. So it is a fixed duration because duration does not change in case of pulse position modulation. Pulse duration does not change, but the position of the pulse gets changed, and it is obtained from the output of PWM only. So PWM output is applied to a monostable multivibrator, okay, and monostable multivibrator changes its state from low stable to unstable state, or low to high, say, and remain in that state for a particular time duration depending on the time constant RC, and go back to the original stable state. So when this change occurs, when the time when the triggering pulse is applied, and that triggering pulse or triggering edge is actually coming from the PWM output. So if the pulse is wide, so accordingly the edge of the particular pulse will take one position, okay, and at that position the triggering will occur, and at that particular positions the pulse will be generated by the monostable multivibrator. So this is the basic operation of PWM and PPM circuits, and that is applied to the transmitter in circuit, transmitter to a LED driver circuit, and that goes to the optical fiber, and finally the receiver photodetector output is considered, and then it is connected to PWM demodulator circuit. And the output of the PWM demodulator is actually contains low frequency, that message signal, as well as high frequency signal. Okay. So we need we need some filter, okay, filter circuit to extract or to get the message signal. Okay. So from the PWM demodulated output. So this is connected here, and filter output, if you see, then you will see some waveform. So first I will show the PWM output. So this is your analog signal. You can see in the CRO. This is your analog signal, and the yellow one. Okay, this is your analog signal of 100 hertz near about, and then it is applied to the PWM modulator, and you see PWM output you want to see. You see the PWM output. You see that this is your analog signal. Okay, it is slightly increasing. It is increasing, and you see the width of the pulse. Initially, it is small because it is magnitude is low. Okay, the yellow one is the analog signal, and this is the PWM output. Now its width is low, and it is increasing slowly as the magnitude increases. So you see but it is not that much visible because you know that pulse width is in the range of millisecond. So it is slightly difficult to observe, but anyhow you can see if the magnitude change is large, it will be more prominent. But here you see it is low width, then slowly it is increasing. It is little higher width because it is at the maximum position. So this waveform, this kind of waveform is required, okay? And it is given in the manual also. You can take the reference from that. And so this is the PWM output. Okay? Now I will show the PPM output. Now you see that pulse position modulation. Okay? Here you see one pulse here, another pulse. This way the pulses are positioned. Okay, now you see the difference between two consecutive pulses increasing as the magnitude of the signal is increasing. Okay. So here it is, let us say it is of, you can see that here here it is from this point to this point, it is it covering 3 dots, okay, and slightly more than that. This is the distance, and the highest at the end, you see the distance between two, okay, is more than 3 dots. So the slight change is there. Okay, so this is the pulse position modulation. Okay. Now, in the demodulation, once it goes through the optical fiber, okay, you just see the demodulated waveform. Connected it to the optical fiber, and at the output, you see that same kind of waveform is coming. That is the not demodulated, it is actually modulated but up propagating to the fiber at the receiver end. So after propagation through fiber, optical fiber, this is your modulated signal. After propagation through optical fiber, it remains same, and you see that fiber is connected, and then you see that demodulated output. This is demodulated output is actually there is problem here. You are just wanted to rectify it, but you are not able to do it because there is some problem. The issue in the clipping type of signal is appearing. So this is the waveform. Actually, it contains the high frequency as well as low frequency. So we have to remove the high frequency terms using filter. Okay, and we see that this kind of waveform is coming, but it is coming in the clipped form. Okay, so there is some issue with the kit. We have to rectify it. So you can see this is the demodulated out. But actually it should come as same as the input one. So so ppm output will be the same one, but except there will be pulses. Okay. There will be pulses at the output. So you can see that this is the ppm modulated wave. ppm wave. Some pulses are not visible because of the sampling CRO, it is DSO. So anyhow, it is that there is changes in the positions of the pulses you can see. So rest you can go through the manual for the actual representation of the waveform. You just go through the manual, and if you have any doubt, you can ask me now. Have you studied the manual?
Yes, sir.
Okay, so do you have any doubt?
No, sir.
Okay, then just note down the waveform, okay, and make the manual for this experiment. And also, many of you have not written the manual of the first experiment properly. Okay. Good. Many of you have not uh, drawn the graph papers, that is similar graph papers. So those who have not drawn, I will cut the marks. So the graph for the analog signal, okay, you have to draw. Many of you have not drawn. So whosoever has not done, just make it corrected and so resubmit it. Okay.
Sir, only the semi-log graph paper was done, no, sir. Square waveforms we could do it normally, no, sir.
Yes, square wave, it is okay, no issue.
Yes, sir.
You
Yes.
can do it normally. Okay, then if you don't have any doubt, then you can leave. Stopping now. Okay.